Welcome to John Stewart's Calculus Early Transcendentals 9th edition. We are going to try to solve problem number 39 here of section 3.1, and the instructions basically tell us to find the equation of a tangent line to the curve at the given point. So let's jump into how to do that. So the first step is to identify what the problem is asking for. In this case, it's very explicit. It wants a tangent line. So what's the formula of a tangent line? The one I like to use is just y equals mx plus b. There's other formats, but that's my favorite. So what three things do we need to find the equation of the tangent line? Well, we're going to need the x-coordinate, the y-coordinate, and a value for the slope. So for the x and y coordinates given in the problem, it's that little bracket 2, 3 at the top. And so the first value in that pair is always going to be x value, and the second value is always going to be the y value. Therefore, you can say when x equals 2, y equals 3 is what this information is giving you. And as for the slope, well, what is a slope? It's the rate of change. And what is a derivative? It's also the rate of change. And what have we been doing pretty much this entire section so far? Taking derivatives. So good odds, the problem's asking you to basically take the derivative, put your x and y values into the derivative to get your slope, and then finally put your x, y, and m values into the equation tangent line to get your offset b, and then eventually, hopefully you'll get a good mark back. So let's go on to the first step here. Before taking this derivative, you have to do a little bit of pre-work to put into standard form. Our polynomial derivative rule is basically when you take the derivative of x to the n, you put the n in front and you subtract 1 from the n. Well, we've got that ugly 2 over x there, so the question is what do we do with that? So luckily we can convert that 2 over x into something nice looking that matches our polynomial derivative rule. Basically what we do is we move it from the downstairs or the denominator to the upstairs by negating the power. So remember that when you have 2 over x, it's really 2 over x to the power of 1. We're just really lazy. I mean, by convention, we never write that to the power of 1. So if we're going to negate that x to the 1, it's going to become x to the power of negative 1, and then we can just move it upstairs. Thus, you can say that 2 over x to the power of 1 is the same as 2 times x to the power of negative 1. So if we put that back into our original question's equation, we would just get x to the 1 plus 2 times x to the power of negative 1. And now it kind of matches our standard derivative format, so we can attempt to take the derivative. If you want, go ahead and pause the video and try to do it on your own. I'll show you how to do that on the next step here. Alright, so next step, taking the derivative. So we can just basically throw it directly into polynomial rule. The way I like to think of it is as being a mini derivative problem, so sometimes I will break it up this way, where I just put the derivative with respect to x of the first term and then derivative with respect to x of the second term. And so yeah, basically all that I'm doing here is I'm factoring out the 2 because it's a constant and it doesn't involve x, that 2 can come out in front. And then now I'm actually taking the derivative on this step. And so what I'm doing is I'm subtracting 1 from the power of the exponent in both cases, and I'm moving the old value of the exponent in front. So in the first term, you had x to the power of 1, so I'm just subtracting 1 from it, and I'm moving that old 1 in front. In the second term, I had x to the power of negative 1, so I'm moving that negative 1 in front. The careful thing to make sure is that you don't mess up on the sign change between those two terms, because you're taking out a negative 1. And then here, I'm basically just following through with that math. 1 minus 1 is of course 0, so you have x to the 0 in the first term. And negative 1 minus 1 is negative 2, so you have x to the negative 2 in that second term. And of course, just remember that anything to the power of 0 is always 1. So if it's e to the 0, if it's 2 to the 0, if it's x to the 0, it's always 1. So a common mistake that sometimes people make is they say c 2 to the 0 and they think, oh, that's 0. So just make sure you don't goof up that way on the test. So of course 1 times 1 is just 1, and then you're still subtracting your 2x to the power of negative 2. And so now we have our derivative. Okay. And so now we are just basically just going to put x equals 2 into our problem here. And what we're doing there is every time we see an x, we're just replacing the x with a 2 literally. And from this point on, we're just doing some basic math. You can move that 2 to the power of negative 2 to the bottom of the fraction by making it positive. And then of course 2 squared is just 4. So the downstairs becomes 4 in that fraction. And another way of writing 2/4 is you can think of as being 1/2. And that 1 you can think of as being 2 halves, right? Because 2 halves is the same as a whole. And so then you can go 2 halves minus 1/2 just gives you a half. So you can basically say that y primed of 2 is just 1/2, or your slope is 1/2. And so now we have our slope. We start to put everything into the equation of the tangent line and solve for unknowns. In this case, we want to find out what b is. Okay, so to recap, we are now going to put the x, y, and m values into the equation of the line in order to find the offset and b value. And to recap again, we know that m is equal to 1/2, which we just found on the previous slide. We know that x is equal to 2 because it's given to us in the problem, and we know y equals 3 because it's given to us in the problem. So we are going to throw our y, m, and x values, which are highlighted in bold to emphasize them, and we're going to solve for our b. So we know that 3 is equal to 1/2 times 2 plus b. 1/2 times 2 is just 1, so we can say 3 is equal to 1 plus b. If we move that 1 across the equal sign, it's a subtraction, so 3 minus 1 equals b. 3 minus 1 is, of course, 2, so you can just say that b equals 2. Therefore, if we go back to our equation of tangent line, we now know our b value. We already knew our m value, so we can just put those two in. M equals 1/2, so you have y equals 1/2 x plus your b value, which was 2. And there you go, you're done. You found the equation to the tangent line. That's all there is to it. So generally, there's going to only be 4 steps. One is that you take the derivative, you put your x and y value into derivative to find your slope, and then you put your x, y, and m into the equation of tangent line, and then you just put your m and b into the tangent line. And that's pretty much it. If you can memorize those 4 basic steps, you'll probably be able to do just about any problem that you encounter. However, there sometimes will be some questions like this where you have to do a little pre-work. We basically had to make that 2 over x look nice before we could apply the derivative rule. So if you see an unusual question that looks ugly, just think, how can I make this into a nice format that matches the derivative rule? And then don't panic, even if it's a test, just follow your 4 basic steps and you'll have the equation to a tangent line. Hopefully this helps.